Hello viewers, some time ago on this page, on this channel, as the case may be, we solved some simple simultaneous equations. 3 of them we have solved earlier. Please go through my page to see if you missed any one of them. I'm going to post the link on this page. But it was actually 5 questions that I put forward for us to use to practice how to solve simultaneous equations. So in this video, I'm going to solve 2 of the remaining questions, and one of the questions you can see on the screen. What are we trying to do here? We are trying to get a solution for x and y that satisfies these 2 equations. This one is going to be pretty straightforward, but the other question, which is question 5 that we're going to solve in this video, is not going to be pretty straightforward. So but please, there's nothing to worry about, just watch out. So, as I've always said, when you want to solve simultaneous equations, the first thing you do is to name the original equations that were given to you. So, we have named this first equation 2x plus 4y equals 42 to be our equation 1. And 6x minus 4y is the second equation. We have named it to be equation 2. We're going somewhere, just hang on. Alright, so in solving the simultaneous equation, recall what I told you earlier. You look at the 2 equations and that will give you a clue which method to use in solving the 2 equations. In this case, we're using the elimination method. That means we want to eliminate one of the variables. And if we want to do that, just looking at these 2 equations, I saw that y, the coefficients of y in both equations are the same. In equation 1, the coefficient of y is 4. In equation 2, the coefficient of y is also 4. So that is the easiest one to eliminate. We look at the signs. This is plus 4y, this is minus 4y, meaning if we add these 2 equations, y will disappear. So that's what the first operation we're going to perform, equation 1 plus equation 2. So equation 1 plus equation 2, 2x plus 6x, that gives us 8x. Plus 4y minus 4y will go away. And then 42 plus 30, that will give us 72. Now we have 8x equals 72. We have successfully eliminated y. So, but x has a coefficient. So what are we going to do? We're just going to divide both sides by the coefficient of x, which is 8. So we'll divide this side by 8 and we'll divide this side by 8. And that helps us to eliminate this coefficient from x. So 8 will cancel 8. So what is left on the left hand side is just x. And 72 divided by 8, that's, check your calculator, that is 9, but that is too simple. You don't even need calculator for that. 72 divided by 8 is 9. So we have got our solution for x, which is x equals 9. The next stage is to substitute the value of x that we just got into one of the original equations. So we have gotten that our x equals 9, and let's take the original equation 1. Original equation 1 was, so we'll now substitute x equals 9. That's 2. Whenever we see x, we put 9. That's 2 times 9 plus 4y equals 42. 2 times 9 is 18. Plus 4y equals 42. We're going to move this 18 to the other side. So that gives us 4y equals 42. When you're moving this 18, it changes sign, so that becomes minus 18. So we now have that 4y equals, that is 24. And this y has a coefficient, so what we're going to do is we will divide both sides by the coefficient of y, which is 4. So, and that helps us to eliminate that coefficient. Y equals because 24 divided by 4 is 6. So x equals 9 and y equals 6. Those are the two values we got. The next thing we want to do is to go back to the two original equations and check whether these values are correct. Alright, so these were our two original equations, and from what we have done so far, we got the value of x to be 9 and y equals to be 6. So we are substituting these values into the two original equations. So let's pick equation 1. We said 2x plus 4y equals 42. Whenever we see x, we put 9. And whenever we see y, we put 6. Does that give us 42? So this is 18 plus 24. What does that give to us? 18 plus 24 equals 42. You can check and confirm. Alright, so we go to the other equation. It says 6x minus 4y equals 30. So we substitute these same values into this. So that means 6 times 9 minus 4 times y is 6. Does that give us 30? Let's continue. So check your calculator. 6 times 9 is 54. By 4 times 6 is 24. And when you subtract 24 from 54, that will give you just 30. Hooray! So these two values that we got, they satisfy the two original equations. So x equals 9, y equals 6 can satisfy the two original equations, making them perfect answers for that simultaneous equation. So this is the next equation we want to work. The fifth question of the given 5 questions last month. And the question is 3x plus 2y equals 7, 5x plus y equals 7. If you look at this question, you will see that the two variables, x and y, none of them has coefficients that are equal in both equations. Did you take note of that? If you take x has 3 as a coefficient in the first equation and has 5 as a coefficient in the second equation. If you take y has 2 as a coefficient in the first equation and 1 as a coefficient in the second equation. So that makes this a little bit tricky, but just watch, is also very easy. So we have tried to name this as equation 1, original equation 1, and this second one as our original equation 2. Now the first step is we will try to make the coefficients of one of the variables the same in both equations. And to be able to do that, let's assume we want to make the coefficients of y the same, because that is obviously easier. We will have to multiply equation 2 by 2. And that will give us a new equation. Watch as we are going to do it. So we'll still drop our equation 1 here. 3x plus 2y equals 7. Nothing has changed in our equation 1. But for equation 2, we're asked to multiply the entire equation 2 by 2. So here we will have 10x plus 2y equals 14. So what has changed? Nothing has changed really. But while this remains our equation 1, this is now equation 3, because this is no longer the original equation 2. We're going somewhere. So now that we have the coefficients of y to be the same in both equation 1 and equation 3, what we can do is to subtract one equation from the other. We can subtract equation 1 from equation 3. Let's do that. If we want to subtract equation 1 from equation 3, that means we have to introduce minus sign to the entire equation 1. And then when we subtract equation 1 from equation 3, we will now add both equations. So we'll now say equation 3 plus equation 1. What does that give to us? We're just adding, but taking note of the signs, because we have introduced a new sign. We said subtract equation 1 from equation 3. So you have to introduce negative to all the terms of equation 1. So if we do that, that becomes 10x minus 3x, which gives us 7x. And the y terms will just go away. These y terms will cancel themselves out, as you can see. Then 14 plus minus 7 gives us 7. Hooray! 7x equals 7. And it's very easy to get our x from there. We just divide both sides by 7, which is the coefficient. And the 7's cancel out. So 7 will cancel 7 here, 7 will cancel 7 here. So that gives us our first answer. X equals 1. Pretty easy, isn't it? Alright, so this is where we stand. This was our original equation 1, this was our original equation 2, and then we performed an operation and we got an equation 3. We have used that operation to get x equals 1. Now we want to look for the value of y, and as we know, if we want to look for the value of y, we substitute this x equals 1 into one of the original equations. So let's take equation, let's use equation 2, original equation 2. So that's 5x plus y equals 7. Wherever we see x, we put 1. So 5 times 1 plus y equals 7. So y is equals 7. We'll move this one to the other side. Of course, 5 times 1 is 5. And when we are moving it, it changes sign. So it becomes minus 5 instead of plus 5. So simply, our y is equals 7 minus 5 is 2. That's it. Pretty easy. Y, x equals 1, y is equals 2. Now we want to substitute these into the two original equations to see if we will arrive at the answer. Let's do it very quickly. So for equation 1, 3x plus 2y, whenever we see x, we will put 1 plus 2. Whenever we see y, we'll put 2. What does that give to us? So this is 3 plus 4. 2 times 2 is 4. Of course, that gives us 7. Hooray! We're good there. Good to go. Our equation 1 was satisfied. So our equation 2. Equation 2 says 5x, whenever we see x, we put 1, plus y, whenever we see y, we put 2. What does that give to us? So 5 plus 1, that's just 5 plus 2. Hooray, that is 7. So both equations are satisfied. This one was a little bit tricky, but not too tricky. We just did something to make the coefficients of y to be the same in both equations, and then we went ahead, used the same method, and we got the answers. I hope this is interesting, guys. Watch out for the next video. Thanks and bye for now.